This is part three of the screencast covering electrical power generation. Once again, this is intended for the use of my various physics classes. In this final part here, I cover some engineering proposals and ideas for the future for generating electrical power. Okay, this engineering proposal or idea is what is called a tidal turbine. Located on a coastline, you would then have the energy associated with incoming and outgoing tides as a means of rotating a turbine, much like a wind farm, for example. However, tidal turbines also suffer from the same problems associated with wind farms, that is, the low energy density. What this means is that you would have to have a lot of turbines in order to generate a large amount of electrical power. Here's an idea using solar power. This is called a solar updraft tower. What you would do is you would take solar panels located here and here along the sides of the tower as a means of heating air directly underneath the tower here and here. And then the heated air at a high pressure would then move through the tower itself and then go out the top of it like so. But as it's passing through the tower, located here and here at the base, you would have turbines, which then rotate a generator, thereby creating an alternating current. As far as I know, this has been proposed. A few prototypes have been built, but as of yet, it hasn't been built on a large scale. There is the possibility of actually using the wave action of ocean swells as a means of producing electrical energy through these prototype devices called sea snakes. But as you can see here from this photograph, they're rather small and they would only be able to generate small amounts of electrical power. And then there is the great hope of the future. The great hope for the future is what is called nuclear fusion. Nuclear fusion is the process of energy transfer that occurs within the cores of stars. So in the core of the sun, for example, there is a process referred to as hydrogen fusion that takes place. You have protons and neutrons coming together to then form heavy nuclei, in this case helium-4. During this process, via the equation E equals mc squared, once again a huge amount of energy is released as heat. So then therefore the idea is to replicate this process on a small scale, control the process, and harness the energy of the nuclear fusion reaction. There are a couple of ways in which this might be done from an engineering standpoint. You might be able to trap the subatomic particles in highly confined magnetic fields, thereby creating the energy density high enough to initiate nuclear fusion. Another option, which is considered much more feasible today, is to use high-powered lasers. That's what's being depicted in the photograph here. Use high-powered lasers as a means of creating the energy density necessary for the nuclear fusion reaction to occur. The problems associated with this, however, from an engineering standpoint, are huge. Number one, you have to confine the subatomic particles to an extremely small space and an extremely high temperature. You're basically mimicking what's occurring in the core of the sun. You also have to be able to sustain the reaction. In other words, you can't just start and stop the reaction. You have to have the reaction continuously occurring over time to generate a continuous stream of electrical energy. And then in addition to that, you also need to be able to maintain that extremely hot environment, the high energy density that is necessary for the reaction to occur. So the engineering hurdles that would have to be overcome in doing this process are huge. And as of yet, we haven't been able to solve the process itself. We haven't been able to solve those problems associated with the engineering. But the promise of nuclear fusion is tantalizing. And the reason why is because you would actually only need a small amount of hydrogen to power the entire world's electrical energy grid over time. For example, to power the energy needs of a mid-sized city over the course of a year, it would literally only require about a gallon of seawater. That's the amount of hydrogen that you would need to then sustain the process for a city over a period of time. So if we were able to ever really turn nuclear fusion into a practical application, it would probably solve our energy problems overnight and it would transform our civilization. So for that reason, nuclear fusion has been pursued for decades as a possible alternative to generating electrical power on a large scale. Right now, the process appears to be getting closer and closer to becoming reality, but the breakthroughs that are necessary for it to become reality are still to be overcome. Okay, that covers then the last part here of my screencast covering electrical power generation.